Hey everybody, today we're going to look at GPT-4 and Perplexity Researcher, which is based on the unified chat class that I had built. So we're going to ask a question. Let's ask a complex one. If I pour a glass of water into the Atlantic Ocean, how long would it take for each water molecule to be distributed evenly? So this is a pretty complex question. When we ask this question, we make a call to GPT to actually ask three different distinct questions, which is going to appear right here when it's available. There we go. So these are the three questions GPT returned. And with these questions, we're going to be calling the Perplexity Search API large language model, which is going to create search and return curated answers for each question and answer pairs. After that, we are actually combining these three question-answer pairs along with the first question, of course, and sending it back to GPT-4 for a final curated answer, which should be appearing here momentarily. Here we have our final answer, the distribution. So we can read this, right? It has quite a lot of information here. And also it's curated out of 3 Perplexity searches. Not only that, we've also saved all the information here into a JSON file, including the questions that were generated, our original question that were generated by GPT, Perplexity responses, and our final answer. And if the longer you query the model, this file will get longer. We'll append to it. So you can be asking it any question. This does internet search and uses Perplexity's 70 billion model from Perplexity API. We'll talk about the code in detail, and I have some extra files here as well, which you might find interesting, but the code files will be available at Patreon. Link will be in the description. But let's take a look at a general structure of how this is working. So we get a user question, just as we have done. We send it to GPT-3 to generate 3 separate questions based on our question. And then we send these 3 questions to Perplexity API to their 70 billion model in parallel using thread pool executor. And then we get each one of the answers for each one of the questions. And then we combine those questions. Then we make a final call to GPT for a curated answer, and we get our final answer. And then we save this entire information to a JSON file, and we keep appending to it. So I have a Streamlit version of this, and I also have the regular terminal version. This is based on unified chat class that I've created, which is capable of making calls to OpenAI, Together API, OpenRouter, Perplexity, Gemini, and Mistral. All you have to do is just set the API keys. If you don't have them, that's fine. Just make sure you don't call that model. But this simplifies. It has methods for calling each one of the APIs. I actually talked about this in detail on my unified chat video. This one right here. You can actually find all my videos at my website, echohive.live. You can also find them on my YouTube channel, but this is a convenient place. You can search. And if you're a patron, you can find all the code download links. But this is the video I'm talking about. If you watch this, I have actually explained the unified chat. So I'm not actually going to get into it. But essentially what it does is it handles making calls to several different APIs. Feel free to modify them or add any other API that you like. It also handles message like histories and all of that for them. As you can see, we are managing the message with max memory of 2,500 words. Yeah, you can change this as well. So by using this unified chatbot, I have actually created the GPT Perplexity Researcher, which we can talk about right now. So as you can see, we are importing concurrent features for parallel processing of Perplexity queries. I am importing unified chatbot from unified.chat. This is our class that I was talking about here a second ago. Now this class, actually, this file, GPT Perplexity Researcher.py, works in the terminal. Like I said, all these files will be available at Patreon. If I run this, we can actually initiate the same process in the terminal. Because we're first going to talk about the terminal version and then the Streamlit chat version, because the Streamlit chat uses this class research workflow. So we can answer a question here. What will be the revenue? For example, what will be the revenue for NVIDIA in 2024? So the process is going to work exactly as it worked in Streamlit chat. We get 3 questions, distinct questions related to our original question. Then we make the Perplexity calls in parallel. So we are querying the Perplexity API simultaneously. There we go. These are the Perplexity responses, all 3 of them. And at the end, we get our final answer. And our data has been saved to the research.data. And as you can see, we've appended to the end of it. So this class is really nice. It uses the other class, Unified Chatbot. We are importing term color for colorful printing to the terminal. So we initialize in the init method our chatbot as the unified chatbot, and that actually has really nice message handling system. So we're just going to set a question message system, which is going to tell GPT to actually create 3 distinct and unique questions based on the original question and return them within these tags. We're not using JSON mode or anything like that. I just wanted to keep it simple. And then we have another system message, which we're going to swap out for. This is for our final answer when we have the Perplexity answers. And then we initialize our thread pool executor to use with the Perplexity calls. And here we have a method which is going to take in GPT response, and it's going to extract the questions out of these tags, which we have mentioned right up here. And it is going to append to a list and return it. And then this is our call Perplexity function. We are actually, so Perplexity, we'll talk about the Perplexity API here in a moment as well, but Perplexity recommends not to keep a chat history when calling their search online 70 billion or 7 billion model. That's why here we are actually creating the chatbot instance of the unified chatbot, and then we make a call to Perplexity, and then we delete that instance. Usually Python's garbage collector should handle that, but just in case if you have multi-turn conversations with this, we're doing this. So we are using this call to create a unified chatbot instance. We make the call, and then we delete it. Therefore, we're keeping our history clean and our memory clean. Each time, this is going to take a question, and then simply use the chat main functionality of the unified chat, this one right here, to make a call to the appropriate API. The unified chat handles all the message history. Anyway, we have the parallel Perplexity call. Here we use the thread pool executor to submit to call the call Perplexity function. This one for each question. And then as they are completed, we actually return them. And then we have another method called curate answer, which is going to take in the Perplexity responses. Here we take the Perplexity responses and we actually convert them into a dictionary, but then here we actually convert them to a string so that we can actually call our OpenAI, right, GPT, with that Perplexity responses. And then here's our method, which actually starts it all, which takes in the user input, which we're going to enter. And we're going to check our self.chatbot.memories, which we instantiate in the unified chatbot, a different message history for each API. And we check if actually the length of it is 0, that means we don't have a system message. So therefore, we are going to actually insert a system message with the question system message, meaning we are going to send the user input and we're going to want to get 3 questions out of GPT. Otherwise, we are going to actually replace the first message with the question system message, because if the length of our memories, meaning the chat history, is empty, then we are going to insert the question system message. Otherwise, we are actually having an ongoing conversation because we are keeping track of conversation history with GPT. Then what we're doing is we're just calling the OpenAI's thread of memory and looking at the 0th element, which is going to be the system message, and we are replacing it with the question message. And then we simply call the chatbot's chat main with the user input and get the GPT response, and then we extract the questions, and then we return them. Then we have a function that just calls the self.parallel perplexity call question with the questions, which is going to call this function, which is going to use thread pool executor to make 3 separate calls in parallel to Perplexity API. And then we have our get curated answer. We are actually, perhaps this was redundant. We actually didn't need this. I can delete it, but I'm going to leave it there because we actually need to reset the system message right here, which we are doing actually. So there's no harm, but that's just an extra thing I was doing. That's not necessary up here. Because in the get curated answer, which means we have the 3 answers from Perplexity, and we do want to reset the system message, like we talk of OpenAI in memories, to the answer system message. Because as you remember, now we are going to ask for a response based on, it says you have been given responses from Perplexity search engine. Your task is to curate a unified answer to these. So that's why we reset the message, the system message to this. And then we just get a curated answer by calling the curate answer function right here method, which actually combines the Perplexity responses and makes a call to GPT. After that, we take in the user input questions, Perplexity responses, and the curated answer. We create a nice little dictionary and we JSON dump it with an append parameter to research data JSON. And then here our perform research method actually it takes in the user input and then calls GPT to get 3 questions. Then we call get Perplexity responses to create 3 answers to those 3 questions using Perplexity. And then we call get curated answer to get a curated answer. And then we save it to file. So this is our main method. And here, when we run this file, we are going to instantiate that class because these above there was only the definitions. We're going to take in user input, and then we're going to perform research. We're going to call this because this returns curated answer and perplexity responses. We are going to take that. We're going to do some printing, and then at the end of the day, we're going to print the perplexity's responses, and eventually we're going to print the final answer, and now we're going to print that. We have saved it to the research data.json. So now let's look at how we can build the Streamlit. This is going to be the easy part once we've done all the hard work. But like I said, all these files will be available at Patreon, but let me take a look at what we have here. So Unified Chat class is the main class here. Every other file here uses this. I also have a chat with any file, which allows you to chat with GPT-4 Turbo, Mistral Medium if you have access to it, Mixtral from Together. Actually, this particular one doesn't work in this configuration. I'm not sure why, but if you find out, let me know. But you can nevertheless, you can access the same model from Open Router. That's why I have it here. You can access the Perplexity and the Gemini from Google. So this will allow you to chat with any one of them. If I actually run this real quickly, you'll see it's going to give us a list of models to chat with, and it'll keep separate message histories with each one of them. Let's just try Mistral from Open Router. So I'm going to select 4. And if I say hi, there we go. This is the Mistral from Open Router responding. And I have a Streamlit version for it as well. And I also have AutoLLM chat loop, which allows you to select 2 of these models and let them talk to one another by setting their system messages and getting them started with a original message. If you watch this video, Streamlit UI, actually, this is really cool. You can see it in action. So I have a Streamlit version for those as well. And the GPT Perplexity Researcher, of course, is a Streamlit UI as well. So every file except except the Streamlit version of Perplexity Researcher and AutoLLM chat loop will be available at Patreon connoisseur level, and all the code files will be available at AI architect level. Also, feel free to check out the new app I built, Code Hive, where you can find 900 plus GPT-powered chat Python applications where you can just browse or search. You can click on any one of them. Here is the code. You can copy and try it out yourself. If you like this, if you like what you see, you can actually download all 900 plus apps at my Patreon for $100 currently. So if we were to review real quick, we see that we built the Unified Chatbot class, using which we built the GPT Perplexity Researcher class, research workflow. And now when building the Streamlit interface, we're going to use both research workflow and Unified Chatbot, which it depends on. And so therefore our Streamlit interface is going to be very simple. Actually, when you build things iteratively like this, you realize that, and if you actually adapt to object-oriented programming structure, then you find that especially working with Streamlit becomes much, much easier. But before we continue, let's talk about what is Perplexity if you don't know it. You can just ask it anything and it'll search the internet and it'll use its model. Currently I'm using GPT-4, but it actually has its own 7 billion and 70 million model, which actually goes ahead and considers many sources. In this case, it only considered 2 sources, but I've seen it consider up to 30 source, and it actually creates a curated answer. Now, that being said, the models here, it offers several models, but it actually offers its 7 billion online and 70 billion online model, which actually has a rate limit of 10 per minute, which is pretty nice. Actually, it's not that much, but nevertheless. So these models will actually search the internet and will return you a curated answer. So what we're doing here is actually we're taking advantage of this rather than doing the search and scraping ourselves. We're relying on Perplexity to do that for us and return a curated answer. But then we are actually turbocharging it by creating 3 separate questions for the original user question from different angles. So it's really wonderful. Since this process takes a second, I mean, I guess you can go as high as, I would go maybe as high as 5. So what I'm trying to say is maybe we could have created more than 3 questions at a time. That's fine too, but I just didn't want to run into the rate limits. So currently we are doing 3 calls to the 70 billion model simultaneously. But since the rest of the process takes about 10-20 seconds, I'm thinking even if you use it nonstop, you shouldn't hit this limit. So that's why I limited it at 3, but feel free to modify it to increase the amount of questions GPT generates to be used with Perplexity. Anyway, we are importing Streamlit. Of course, we are importing Unified Chatbot from our Unified Chatbot file and the research workflow class from the GPT Perplexity Researcher.py. And then let's actually delete this, okay, and run it, see what happens. To run a Streamlit app, you create a terminal and you type in Streamlit, then run, and the name of your file, here in this case, st_gpt perplexity researcher.py. When we run this, let me actually move this to the side, just like that. See, we have started our Streamlit, and if you refresh it, all we see is GPT-4 Perplexity Researcher because that's our title. Now let's add back the rest of the stuff. Because we added back the code, it's actually asking us to rerun. And here we go, that we got the question and the submit button. So we are initializing the chatbot. So here what we're doing is because Streamlit, every time you take an action in the Streamlit interface, this entire Streamlit script will rerun. So therefore, if you're keeping track of any history, message history, or any other variable that you need throughout your interaction with the web page, those are all going to be reset, right, to their original values that you set in your script. So therefore, Streamlit, to avoid this, have a session state. So we are checking if chatbot is not in st.session state. We instantiate the unified chatbot as st.session state chatbot and the research workflow as st.session state research workflow. Then we have the user question with st.text input, which is this one. And here we say if st.button submit. So therefore, this can't be initiated by just a press of enter on the keyboard. Then because we have instantiated the research workflow agent within the st.session state, we just call it research workflow, get questions. Remember, this is just a method that we talked about with the user question. That's going to give us 3 separate questions. And then we write st.markdown GPT questions, and we enumerate over those questions. And then we use some HTML style with st.markdown, and then we print them. So if I were to ask a question, let's ask how many atoms are in a grain of sand. So when I click submit, this activates, and then we make a call to GPT to get 3 questions. And after that, this should now print the 3 questions. Say this. After these questions are printed with this for loop, then we're going to call Perplexity to get answers to each one of them. With the st.session state, research workflow has the get Perplexity responses method, as we've talked about. And when we get them, we're going to loop over again, and we're going to write the questions on the screen with orange. And right after that, we're going to print the answers in regular color. This is the first question, first answer, second question, second answer, third question, and then third answer. Right after that, we're going to grab those answers, and we're going to call the get curated answer method with those Perplexity answers. And then when it becomes available, we're going to use the st.setChat message with the assistant role. That's why we're going to see a robot icon here. And then we're going to just print it regularly. After that, we're going to call the save to file method in research workflow. But remember, it's in our session state. There we go. This is our final answer, which is very detailed, as you can see. And now we just print a success message at the end that our data has been saved. And as we can see that it has been appended to our JSON file. So I hope you enjoyed this. I am actually working on a fast API, full stack web app with this as well. Once it's ready, I'll make a video about that too. Maybe I'll add in some additional improvements. But other than that, remember, you can always find my projects, other projects at EchoHive AI Academy at echohive.live. Here's the Gemini salesperson, for example. I created a new kind of memory, which was a great experiment for me. Take a look at that. I regularly have live sessions too, maybe every 2 weeks or so, and other than that, this is the GPT sales agent. Take a look at this one too, and this one, they are very interesting. Also, I'm building a GPT masterclass. Well, it's more like a crash course. So this one is actually available to connoisseur level patrons, but it is also available in my shop for $40. So it's $10 cheaper if you become a patron. So it covers the new OpenAI library, everything API assistance API step-by-step, instructors for tool calling, GPT for vision and speech samples, DALL-E 3 and text-to-speech, older OpenAI library. I have code files and video descriptions for each. Take a look. Thank you for watching, and I hope to see you in the next video.